What is up, YouTube? Today I have this pretty fun forces problem for us. So in this problem, we have two blocks that are connected by this string right here. And there's a force being applied to block A, and we know that that force is 60 newtons. Block A has a mass of 15 kilograms, but block B has an unknown mass that we are just going to call M. And this one over here has a mass of 15 kg. So it's asking us to solve for two things. It's solving us to ask for the tension in the rope, T, and it's asking us to solve for the mass of block M, which we call M. So the information that was given to us was the mass of block A, this force right here, which is 60 newtons. And it also tells us that in the first 5 seconds after the force is applied, this block A moves 18 meters to the right. So from this line of information, we can determine the acceleration that A underwent. So very quickly, I'm going to draw a free body diagram, of A on the side over here. So we know that if this is block A, there's a weight acting on it, gravitational force, which is its weight. Normal force, these cancel out perfectly though. And on the left of it, there is a tension force that's acting on it from block B. We're going to call this T. And there is a force we apply over here. We'll call that. We know that the net external force is to the right because it is accelerating to the right. So the summation of forces, net force acting on A, is going to equal this force on the right that we apply minus the tension force, and that's going to give the block an acceleration. So we're going to set this equal to ma, and we know that this force is 60 newtons. And right now for A, we're trying to solve for T. So we're going to leave T as T, and that's going to equal ma. So putting T on the right side of the equation, T is going to equal 60 minus the mass of block A, which we know to be 15 kilograms, and the acceleration. So now let's solve for the acceleration. We know that the displacement x is going to equal, and there's no initial velocity, so it's just going to be 1/2 times a t squared. This is the acceleration, so a is going to equal to 2x all over t squared. The displacement was 18 meters, so it's going to be 36 meters, and the time was 5 seconds, so 5 seconds squared. It's going to be 25 seconds squared. We're just going to leave this like that for now. So this means this tension force is going to equal 60 minus 15 kilograms times 36 over 25 meters per second squared. And then putting this all into the calculator, we are going to get 38.4 newtons. And we know that that force is acting onto the left. So T is going to equal 38.4 newtons. So now we solve for T. Now it's asking us to solve for M. So we know that together this whole system is undergoing an acceleration, and there's a net force acting on it. So we know that the net force divided by the acceleration of the system is going to equal m of the system, but we know the mass of the system is going to be m, the little mass of B, plus 15 kilograms. So solving for m, we get m is going to equal net force over A minus 15 kilograms. We know the net external force acting on the system is 60 newtons, and because the acceleration of block A is 1.44 meters per second squared, that means that it's also the acceleration of block B, of the whole system. So this is going to be, the mass is going to equal 60 newtons divided by 1.44 minus 15, and taking a big loop over here, the mass is going to equal, let's do a little computation, times 60 minus 15. That gives us a mass of 26.67 kilograms. Okay, thanks for watching. Don't forget to like and subscribe, and please leave a big fat like on this video. I already said that. Thank you.